In the wild, hesitation has no function. Each heartbeat carries consequence. Each breath can be the final breath. This environment is dominated by specialized predators, Examples range from bone-crushing jaws of hyenas on the savannah to the coordinated hunting strategies of oceanic orcas. Survival is determined by physical strength, speed, and rapid strike execution. The question is not which species prevails. The question is how far biological systems operate at the edge of mortality. As darkness spreads, predators begin structured movement. The boundary between dominant species and prey narrows to a single engagement. What follows includes primitive behaviors, lethal confrontations, and hunting strategies refined through millions of years of evolution. This is natural dominance selection. Weaker individuals become nutritional input, stronger individuals define outcome. The severity of Akagera and the Serengeti begins with atmospheric conditions. Here, solar radiation functions as a limiting force rather than a resource. During the dry season, ecological systems enter a state described as negative energy balance. moisture availability declines. The environment becomes thermally extreme. Mortality rates increase across trophic levels. In Rwanda, Akagera National Park consists of dense thorn scrub and contracting water bodies. Extreme heat transforms each section of land into a high-energy cost zone. Herbivores must make continuous survival decisions. Movement follows a behavioral model known as the landscape of fear. For wildebeest and zebras, the savanna functions as a risk matrix rather than open pasture. The landscape of fear guides movement based on ambush probability. Areas with higher quality forage often coincide with limited visibility zones near brush or river bends. These zones function as high-risk predation areas. Fear acts as an ecological regulator. It limits overgrazing. It reshapes vegetation patterns. It controls energy transfer across the system. As forage energy declines, survival pressure increases on herbivores. Each step taken by an aging buffalo represents a cost calculation. Remaining calories must support movement toward water while avoiding thermal stress or attack. Energy flow within this system involves violent transfer rather than gradual exchange. Silence across the Serengeti reflects maximum tension. Predator sensory systems remain fully engaged. They wait for error rather than opportunity. Within this arena, error does not produce failure. Error produces individual elimination. If the Serengeti functions as a battlefield, the lion pride serves as its most effective unit. Unlike solitary felids, lions operate within a matriarchal social structure. Adult females manage territory, defense, hunting coordination, and food acquisition. Male lions contribute symbolic dominance. Lionesses provide tactical intelligence and approximately 90% of prey procurement. Lion hunting does not rely on pure speed, as seen in cheetahs. It relies on stealth and ambush. A hunt led by Near emphasizes controlled movement and patience. Vegetation and terrain features reduce detection distance. The final engagement zone measures approximately 98 feet. Failure to close this distance results in hunt termination. Energy conservation takes priority over pursuit. From a biomechanical perspective, lionesses operate as optimized predation systems. Forelimb's strike force can reach several thousand pounds of applied pressure. This force is sufficient to cause immediate spinal trauma to large ungulates. Target fixation, immobilization, termination. The primary advantage of Near's pride lies in coordinated group execution. Lions are the only large felids capable of multi-role cooperative hunting. During buffalo engagements, roles are distributed. Drivers apply directional pressure. Ambushers position along projected escape routes. Communication occurs through visual cues rather than vocalization. This is not disorganized instinct. It is calculated group predation. This coordination establishes lions as a dominant force across the savanna. Within the political structure of the savanna, spotted hyenas do not operate under a monarchy. They function as a militarized republic with a strict matriarchal social system. This structure ranks among the most complex in the animal world. Zawadi, the leading individual, maintains authority through collective intelligence rather than individual strength. Behavioral studies show that hyenas demonstrate problem-solving abilities comparable to several primate species. This capacity positions them as a primary competitive force against lions. The most effective weapon of this group is located in the jaws. Bite force reaches approximately 1,100 pounds per square inch. This force allows hyenas to fracture the femur of an African buffalo. Even lions experience difficulty processing bone at this level. Specialized digestion enables consumption of skin, muscle, bone, and horn. This efficiency allows hyenas to utilize all remaining caloric resources in arid environments. In this system, waste reduces survival probability. Primary risk presented by this group lies in acoustic communication. Vocalizations function as structured signals rather than random noise. Pitch and rhythm transmit information regarding location, group size, and prey priority. When Zawadi initiates a call sequence, dozens of individuals converge from multiple directions. Assembly occurs within minutes. This communication system supports numerical advantage. Hyenas recognize that single individuals are not effective against lions. At ratios of 4:1 or 5:1, suppression becomes possible. Psychological pressure is a core tactic. The group surrounds the opponent. Vocal output increases to disrupt focus and coordination. Engagement intensifies as fatigue develops in the lion. Resource transfer follows sustained pressure. On the savannah, these vocalizations indicate imminent competition for food access. Antarctica is an environment of extremes. Cold functions as a constant ecological pressure rather than a temporary condition. Within these dark and frozen waters, a highly developed cognitive predator dominates. These animals are not defined solely as killer whales. They function as apex strategists. Antarctic orcas, Orcinus orca, do not form a single uniform population. They exist as a stratified society composed of distinct family groups. Scientists classify these groups as ecotypes. This differentiation explains the ecological dominance of orcas. Researchers identify 4 primary groups. They are designated Type A, Type B, Type C, and Type D. Each group occupies a specific ecological role. Type A individuals operate in open water. Large body size allows interaction with large prey such as minke whales. Type B individuals are smaller and highly maneuverable. They specialize in hunting seals and penguins near ice formations. Type C individuals inhabit dense ice regions. Their primary food source consists of Antarctic cod. Type D individuals remain the least observed. Distinct cranial structure is associated with activity in deep and remote waters. The primary factor of interest is dietary specialization. Type B individuals may ignore abundant fish resources. This behavior reflects cultural transmission rather than immediate availability. Each ecotype maintains learned foraging preferences. Dietary behavior is transmitted across generations. Food selection follows established group knowledge. Even within shared waters, interaction between ecotypes remains minimal. Interbreeding rarely occurs. Each group maintains distinct behavioral boundaries. This system extends beyond instinct-driven feeding behavior. It represents structured social differentiation within a marine predator. Social stability is maintained through matriarchal organization. Leadership resides with older females. Multi-generational family units function as coordinated groups. When a Weddell seal retreats onto a drifting ice floe, it assumes safety from predators below the surface. For Aurora's Orca group, the ice floe does not function as a refuge. It represents a physical variable to be analyzed. This sequence presents one of the most complex hunting behaviors ever documented. The method is known as synchronized wave washing. This behavior does not result from spontaneous instinct. It reflects precise application of hydrodynamic principles. The operation begins with reconnaissance. Aurora leads the group at the surface. Target location is confirmed. Ice flow, size, thickness, and stability are evaluated. Group members align in a straight, lateral line. Spacing remains uniform across individuals. Immediately before contact, all individuals dive simultaneously. Tail strokes generate forward displacement of a large water mass. This collective tail movement produces a convergent wave. Single individual movement produces dispersed wave energy. Coordinated group movement produces additive wave peaks. Wave interaction increases pressure at the ice surface. The result is sufficient force to clear objects from the flow. Timing accuracy determines effectiveness. Deviation by one individual reduces wave integrity. This sequence represents fluid mechanics synergy at maximum efficiency. Orca dominance in Antarctica is not determined by genetics alone. This segment examines the most demanding learning environment on Earth. Juveniles acquire intellectual legacy from Aurora and older generations. For killer whales, wave creation and prey isolation are not innate behaviors. These abilities are learned skills. Training occurs over many years through repeated practice. Observation reveals how an adult female interacts with a juvenile after a wave displaces a seal into the water. They learn tail propulsion to generate water pressure. They learn coordination with other group members. Errors are corrected through repeated guidance. This process preserves accumulated knowledge across generations. This open ocean learning system faces an unprecedented challenge. Ice habitat stability is declining. Climate change alters survival conditions beyond temperature metrics. Ice loss removes critical training environments. Seal and penguin resting platforms decrease rapidly. Initial assessment suggests increased prey vulnerability. Long-term consequences reduce learning opportunities. Loss of ice floes reduces the effectiveness of wave washing. This technique represents a central element of the Aurora lineage. Environmental change removes the conditions required for practice. Skills refined over thousands of years lose operational context. This pressure forces rapid cultural restructuring. Orcas must locate alternative prey sources. New foraging areas present unfamiliar risks. Adaptive intelligence determines survival outcome, while other species decline. Orcas modify behavior. Aurora directs experimentation in open water environments. Collective problem-solving compensates for habitat loss. Success remains uncertain. The margin between persistence and extinction remains narrow. Orca legacy extends beyond hunting efficiency. It includes continuous learning capability. Intergenerational knowledge transfer enables rapid adjustment. When a juvenile executes a complete wave maneuver under maternal supervision, survival probability increases. This outcome reflects effective knowledge retention under environmental instability. In the Everglades wetlands, survival is not defined by speed. The central figure here is Old Moss, a massive American alligator. Its dark, weathered scales reflect decades of survival. Within this ecosystem, the alligator is not only an apex predator, if old moss were removed, the biological structure of the Everglades would collapse through cascading effects. The true influence of old moss lies in a unique form of environmental engineering. This behavior is known as the creation of gator holes. During severe dry seasons, water retreats from sawgrass plains. Large areas of the Everglades become hostile to life. Old moss uses its snout tail and powerful claws to excavate limestone substrate. These excavations form depressions that retain water throughout the year. These gator holes function as life-sustaining refuges. During extreme drought, fish, turtles, wading birds, and small mammals converge on these sites. Old moss tolerates temporary coexistence around the water source. In return, the alligator maintains reliable access to prey. From a biological perspective, old moss represents a lineage dating back to the Cretaceous period. American audiences observe extensive evolutionary adaptation in this species. Unlike saltwater crocodiles, American alligators primarily inhabit freshwater systems. Old moss demonstrates adaptations that allow survival in brackish environments. Although salt excretion glands are less developed than in true crocodiles, thick skin and osmotic regulation permit limited estuarine hunting. Minute integumentary sensory organs line the jaws. These receptors detect subtle vibrations in turbid water. Old moss operates as a silent presence beneath the surface. Within the Everglades, old moss does not merely persist. It actively shapes ecological structure. In the center of the marsh, survival may depend on unexpected alliances. The interaction occurs between American alligators and wading birds such as great blue herons and egrets. birds construct nests in trees above old moss's gator holes. Protection explains this nesting choice. Alligator-occupied waters form barriers. Old moss indirectly provides security by occupying the water below. This system preserves colony survival through limited individual loss. Bird colonies also provide a secondary advantage. Movement and vocalization attract fish and small animals. These organisms approach the water source unknowingly. This sets the conditions for silent ambush behavior. Old moss remains motionless for extended periods. Only eyes and nostrils break the water surface. Pressure-sensitive receptors along the jaws detect minor surface disturbances. When prey enters effective range, movement remains slow and submerged. Tail propulsion allows precise positioning without surface disruption. The final strike occurs in less than 1/10 of a second. Jaw closure delivers crushing force. A rotational death roll may be applied if required. This sequence reflects evolutionary refinement over millions of years. In the Everglades, stillness functions as warning. Camouflage, combined with avian association, establishes old moss as a dominant ambush predator. The return of grey wolves and brown bears to Croatia's old-growth forests is not only a conservation success. It represents the reactivation of a large-scale biological system. When these apex predators reclaim their territories, they trigger a process known to ecologists as a trophic cascade. This process demonstrates how a limited number of top predators can reshape an entire landscape. The influence of grey wolves on vegetation is direct and measurable. Before wolves returned, herbivores such as red deer and wild boar expanded unchecked. Overgrazing damaged young trees and riverbanks. With wolves present, prey behavior changed. Deer now avoid open valleys and exposed lake shores where ambush risk is high. Brown bears function as major energy regulators within the forest. Survival in Europe's old-growth forests reflects a balance between strength and caution. Bears and wolves coexist under constant interspecific competition. Bears frequently use physical strength to displace wolves from carcasses. This pressure forces wolves to hunt with greater efficiency. Together, these predators transform the forest into a dynamic system. American audiences will recognize that predator lethality is a precise natural mechanism for sustaining long-term life. Beyond the limestone forests lies Croatia's final ecological engine. The Adriatic Sea is not only a tourist destination, it is a highly protected center of marine biodiversity. Croatia has placed approximately 47% of its marine territory under conservation management. Beneath calm waters, marine life operates as a coordinated system. The Adriatic supports stable populations of bottlenose dolphins. These dolphins form smaller groups with strong social cohesion. The consistent presence of dolphins serves as a biological indicator of ecosystem stability. Within dense Posidonia seagrass meadows, seahorses persist. These animals rely on camouflage and anchor themselves using prehensile tails. Their survival depends on water quality and intact limestone reef systems below. By protecting nearly half of its marine area, Croatia maintains buffer zones that limit pollution and overfishing. These measures prevent the loss of vulnerable species. The Adriatic marine system concludes with a message of coexistence. Protecting 47% of marine territory safeguards not only dolphins and seahorses, when human pressure is reduced, natural systems recover. Croatia demonstrates that national development and intact wilderness can coexist.